Great, let's begin. So thank you again for joining us today. My name is Erin Daly, and on behalf of Everbridge, I'm excited to present this Expert Insights webinar, Severe Weather 2014, Predictions and Best Practices with WDT. In this webinar, our presenters will examine what's in store for the upcoming season, best practices for leveraging forecast data, and solving severe weather communication challenges. After the session, we will have a 15-minute Q&A session with our speakers. As a reminder, you can submit your questions at any time during the webinar. You may send your questions by typing in the open text field in the questions panel and sending your question to all panelists. If time runs out before your question is asked, we will try to follow up with you after the webinar. Links to the recording of the webinar and slides from today's presentation will be available on our blog within a few days of today's session. You can also look for a link to recordings for all of our webinars on everbridge.com under our resources section. If you're on Twitter, we encourage you to take a moment to follow us at @Everbridge and to use the webinar hashtags #Everbridge and #WeatherPrep to share snippets of insight throughout our program with your followers. And we will try to retweet some of your comments. And now I'd like to introduce you to our speakers. From WDT, we have Mickey Lee. Mickey has a degree in meteorology from Texas A&M. He has worked almost 30 years in the commercial weather business. He has spent much of that time helping to guide businesses and large organizations in effective ways to utilize the latest weather technology and information to protect lives, plan for emergencies, and respond to major weather events. He is currently Director of Business Development for the energy sector at WDT. We also have Dr. David Gold, Senior Scientist and Forecaster from WDT. David has a PhD in Atmospheric Science and an MS in Meteorology from Texas A&M University, along with over 6 years of meteorological support experience in the energy space. He has independently developed several proprietary analog and pattern matching tools, as well as a sophisticated framework for performing regression-based and canonical correlation analysis based weekly, monthly, and seasonal forecasts. David is an extremely involved and respected member of the private sector meteorological forecast community and has a special interest and expertise in identifying the type of pattern transitions that lead to severe weather outbreaks and the large-scale patterns that tend to support their occurrence. After WDT's presentation, we'll be hearing from Claudia Dent, Vice President of Product Management at Everbridge. Claudia has many years of experience in the technology industry and has held executive positions in product management, marketing, business development, and general management at companies ranging from startups to large global enterprises. And we're excited and honored to have all of our speakers here with us today. And now I'd like to turn it over to our first presenter, Mickey Lee. So Mickey, you may begin.
All right. Thank you, Erin. Let me go back to the right slide here. For those of you that joined us for our winter weather webinar, welcome back. For those of you joining us for the first time, this is our kickoff to the spring storm season with a heavy emphasis on tornadoes. As you may know, WDT is the provider of weather feeds to Everbridge that drives the weather content in the Smart Weather Alerting platform. This afternoon, I'll talk a little about why understanding severe weather is important and ways that we can mitigate the effects on our businesses and operations and keep our people safe. Then my colleague, Dr. David Gold, will give us the scientist look at what expectations we can and can't have about this upcoming severe weather season that's right on our doorstep. So WDT was founded in Norman, Oklahoma. In Oklahoma, football is one thing that we do exceptionally well, especially here in Norman. Another is weather, especially severe weather. WDT was founded here in the year 2000. Our founders came from the National Severe Storms Lab, where they were working on building out capabilities of the NexRad radar system and developing enhancements to detect downbursts and gust fronts and microbursts and help keep aircraft from flying into those kind of situations. And they founded WDT to apply some of the technology that they had worked with to commercial applications. So Norman is also home to the National Weather Center. It houses the National Severe Storms Lab, the Storm Prediction Center, the local Norman Weather Service Forecast Office, OU School of Meteorology, and a collection of other federal, state, and research organizations involved with weather and climate. These organizations, along with several commercial weather companies like WDT, form a consortium that has become a sort of mecca for meteorology. There's about 1,200 meteorologists that work at this growing collection of government, education, and business spread out in 6 or 8 buildings on the South OU campus. So WDT has been recognized both as a rapidly growing business enterprise and as an award-winning private weather corporation. Driving that exceptional progress is a collection of experts, over 40 of them with advanced degrees, that have been recognized for bringing the latest meteorological technologies from research to real-world applications. So most of our 90 employees are meteorologists who, because we are not accidentally planted firmly in the famed tornado alley, are seemingly all primed to run out of the building and jump in the car to chase a tornado at the next glance at the radar on their desktop. Real-world application of skills and technology, you might say. Well, I can say that that is what we do. We bridge the gap between research and practical application of weather tools for making mission-critical decisions. So we offer expertise in radar data exploitation for hazardous weather detection and prediction, for forecast modeling, geographic information systems, and decision analytics specifically designed as decision tools. Some of the world's largest companies, as well as some of the leading weather forecast companies, rely on our advanced systems and services. Also, WDT employs a large staff of expert meteorologists we call the WeatherOps team. Those professionals provide global consulting, monitoring, and specialized forecasts that utilize and complement our technologies. And backing all this up is big data operational support that ensures we can process the vast amount of incoming data and millions of web views, emails, and alerts. So today we're here to talk about severe weather and its effects, from tornadoes to hail to lightning to flooding, and how it can threaten individuals and businesses. The same kind of weather that can put lives at risk also can put businesses at risk. Of course, power outages, damages to facilities, those economic impacts, they all become interrelated. And most of those kinds of events and disasters result from severe weather and storms. We, as humans, are especially vulnerable to severe weather when we congregate out of doors. After the shocking events of the Indiana State Fair in 2011, just prior to a Sugarland concert, you probably heard how a windstorm caused a stage collapse. It led to 7 deaths and dozens injured. WDT was invited to speak to an industry association and to help form what became known as the Event Safety Alliance. We've now expanded that involvement into a thriving business for outdoor events all around the world. Just last year, our advisories aided the evacuation and the dispersion of the entire Lollapalooza event in Chicago, while a severe thunderstorm passed across the event site. And our forecasts helped to shelter concert goers at a Linkin Park concert in Austria for a couple hours while a damaging storm passed over the site. WDT continues to refine the processes and technologies that we use to ensure the safety of those, well, there are literally millions at outdoor events. We forecasted for the Olympics, for NCAA football, NFL, and concerts all across the U.S. and around the world. So some concert tours and some of the venues have even taken on the Storm Ready program. It's a National Weather Service certification that assures the operators are properly prepared for severe weather. And WDT has assisted the tour operators and some of the event sites in this process. One of the requirements to being storm ready is having a third-party weather provider. And in the picture you see there is the rock group Lincoln Park and some of our WDT team members. We've also assisted the Heart concert tour to become storm ready. So weather information constitutes a huge flow of data. So this is where WDT's big data capability allows us to process and utilize that vast amount of data. For instance, during the Moore tornado event last May, we disseminated 2.1 million tornado warnings to mobile devices and emails in less than 30 seconds. That event was almost right on our doorsteps, 5-6 miles away from WDT's headquarters. So the U.S. is home to tornadoes, and Dave Gold will offer some insights in a few minutes as to why that is the case. But tornadoes are close to home here at WDT in many ways. Not only are we inclined to go jump in the car and chase the next tornado that's close by, but we've developed some specialized tools for decision making around tornadoes. One of those is our Tornado Tracks tool that describes the path of a tornado based on Doppler weather radar data and display it in a number of mapping platforms like GIS. Within minutes after the tornado passes, it will paint the high probability damage path so that emergency personnel or utilities personnel know exactly where to respond to begin assessment and or restoration efforts or whatever kind of response is appropriate. So another business that has chosen to use this tool is the Walgreens. They have over 13,000 stores, most of them in North America. So it's not uncommon for them to be in the path of a tornado. And the blue dots that you see on the map there represent the existing Walgreens stores after the May 20th tornado in Moore, Oklahoma. There's 2 dots that are missing that were in the path and destroyed or had partial damage in that event and were at least temporarily shut down. To the right, you see the fan here is a future cast product of where the tornado would go if it stayed on the ground. So what you see on this slide is a real-time radar path analysis of the storm's previous path and its future path. It's a powerful visual tool. So when we talk about weather forecasting guidance here at WDT, we like to think of a forecast funnel. It gives you situational awareness from the earliest assessments or forecasts of a severe weather event. So that starts sometime in that 7 to 10 day time period from when an event occurs, when all the technology and modeling and meteorologists' analysis can begin to focus on the timing and the geographical target or extent of a potential severe weather event. As time of the event approaches, we begin to narrow down the time period and the threatened geography and elevate the accuracy and confidence as well as expanding the details of the severity or type of effects that are expected. As you reach 1 to 2 days before the event, outlooks and watches are issued, and once within a few hours we move into what we like to call the nowcast period of 0 to 4, 5, or 6 hours when warnings are issued and the event may be seen on radar, and the immediate type warnings such as severe thunderstorms or tornado warnings are issued. All along this process, the human forecaster can add valuable input all along the way. So in that very short fuse situation, like a tornado where a few minutes can make all the difference, in the future we'll be able to augment official tornado warnings with additional detail about timing and level of threat beyond what the official warning provides. As you can see, there's 3 yellow location sites, crosshairs, and there's the red outline indicates where a tornado warning has been issued. And there's 2 of those locations that are inside that tornado warning. So the one here in the direct path should be under high alert with the tornado only a few minutes away. The one in the far right is under what you could call a moderate tornado threat. It's inside the warning area, but it's not really in the direct path. And this would be updated with every radar cycle every 5 or 6 minutes. And but the one on the far left here is outside both the warning area and the augmented threat area designation, so they would receive no alert. So this is the kind of tool that we build here at WDT. So we can bring together a variety of tools and technologies to expand the decision making around weather events, from tornadoes to windstorms to hurricanes to winter precipitation, winter storm events, and display them all seamlessly on a client's internal mapping system, or GIS, or on our hosted website, or even on mobile devices. And we can also bring our expert forecast team, people like Dave, to advise around major decisions, be it evacuations or business shutdowns, or planning around your business continuity program, or even for weather briefings, in the preceding a major weather event. So for now, or for more now, about the upcoming tornado season, I'll hand off control to my esteemed colleague, Dr. David Gold. Dr. Gold is not only a renowned forecaster who plies his trade every day with some of the most cutting-edge forecasting methodology in the science, but he has a special relationship with tornadoes. He has been a partner in a storm-chasing tour company for many years. He will tell you that nothing challenges a severe weather forecaster quite like trying to figure out where to pre-position a tour of paying customers for the next day's chase, and then keep them all happy with all the logistics required. So, Dave, with that, I'll hand it off to you.
All right. Thank you, Mickey. Yeah, I am no longer in that business. I'm happy to report. Had a fun few years with that, but now I will just forecast them without having to answer to clients other than clients here at WDT. So I wanted to take an overview of the tornado season, but before I did, I thought it would be interesting to take a look at some of the numbers and to kind of put things in perspective. I'm kind of a numbers guy, and I know many of you may not be very familiar with this. We've had what we call inflation in the minor tornado reports, meaning EF1 or weaker. And so what I've done is I followed SPC, the Storm Prediction Center, and I've used their methodology to detrend the tornado counts. Now what I'm showing here are the annual tornado counts, and actually you can find this same graph on their website. Again, these are the annual totals, and basically what these are numbers that are adjusted to the 2007 total, which was about a little over 1,200. And so what's done is that if you look at the raw data, there's a linear trend evident because there are more people available to witness these storms, including storm-chasing tourists, and a lot more video cameras and just more documentation in general, more population, and so there have been far greater number of sightings of relatively small, weaker tornadoes, and that has inflated the numbers. So the logical thing to do to get a sense for, to answer questions such as how anomalous was the tornado activity in the United States this year, the thing to do is to simply take that trend out and then, sort of pick a year that you think is representative of, the annual tornado counts that you might see. in an average year and simply adjust to that baseline, and that's what's been done here. And when you do that, what jumps out at you is that the last two seasons, the 2012 and 13 tornado seasons, well, again, these are the entire years, they're very anomalously below, below the baseline. In fact, going back to 1954 or 1953, there's really no precedent for this. These last 2 years really stand out. But if you look at those data points in the context of the whole data series, it's hard to draw any conclusions from that. And this is just part of the variability that exists in a record like this. You don't have to go back very far at all. In fact, 2011 here, this was a very above average year, and here I think is 2004. So there's just a lot of up and down, but the last 2 years really were below normal. And so logical question is, are we going to bounce back up, way back up, or something closer to normal, or have another below normal year? Let's look at the numbers in a different way. I've taken the most recent top and bottom U.S. tornado seasons. Now we're looking at, again, adjusted numbers using the same method that I described before, but only considering numbers from March through June. And just, again, getting a sense for this, you can see how much year-to-year variability there is in U.S. tornado activity. 2011 here ranks as the top overall year for adjusted tornado activity for spring. Again, the annual numbers, that wasn't the case, but for spring values, 2011 was apparently the top year if you adjust these numbers, whereas 2012, but that would have been a new record low. So one thing I've also done here is we are apparently going toward an El Nino event. It's not clear how strong or how durable it will be, although quite a few people are jumping on the strong El Nino bandwagon right now because there are a lot of data that suggests that we're going that way. So what I've done is I've highlighted in blue years that finished up with an El Nino, and I've highlighted in red years that have ended up in a La Nina. And what you see is relatively few. Again, I've only got 8 data points here for the top tornado years and the bottom tornado years in the most recent set of years. But you see relatively few of the top years are El Nino years, and relatively few of the inactive tornado seasons tend to have finished with a La Nina. And we'll touch on that again soon. What are the ingredients that have to come together to produce major severe weather outbreaks? If we're going to try to approach any kind of a long-range tornado or severe weather outlook, it's helpful to know what factors you have to look for to try to make such a prediction. So what are the ingredients that come together for severe weather? Well, particularly for the high-end severe weather outbreaks, those are the ones that produce significant tornadoes and the most damaging hail. You invariably see a region of westerly winds at higher altitudes, or winds that have a westerly component. Sometimes they can be blowing from the northwest, sometimes from the southwest, and this is usually associated with the jet stream. And in fact, for the most violent severe weather outbreaks, what we almost always see is an upper-level low-pressure system that evolves over the interior western United States and moves east. And I've marked that here accordingly. There is cold air aloft associated with that low-pressure system, and some of that overspreads a stream of rich low-level moisture that comes up from the Gulf. It's the flowing of that, the northward flow of that rich low-level moisture from the Gulf of Mexico and Caribbean beneath that cold air at higher altitudes that sets up the necessary energy for these storms to develop. And an added airstream that often gets involved with these outbreaks is a layer of air that comes off the high desert plateau of northern Mexico. And that air mass actually serves to hold off thunderstorms until the peak heating of the day and until the various mechanisms that act to lift the air from the moist low levels upward to higher altitudes until that has had a chance to act all day. So that dry desert air, which is naturally warmer than the underlying moist air, that tends to what we call produce a cap. It caps off convection until late in the afternoon. And so all of those air masses superpose and lead to a lot of energy. And also note how I've drawn these air masses to be blowing from different directions. It's typically the case that the moisture is coming from the south. Logically, that's where our moisture source is at low levels. Desert air coming from the high plateau to our southwest, and typically the cold air stream moving in from the west. And that airflow at different levels is highly sheared, meaning the winds exhibit a strong change in direction and/or speed with height. And so air that is flowing into a developing thunderstorm within that type of sheared environment is rotating. And the thunderstorm lifts that. You can almost, envision what would happen if you put a paper towel roll horizontally in that airstream. The winds at the top of that, imagine a really giant paper towel roll. The air at the top of that is blowing from the west more strongly than at the bottom of that, and so it rotates horizontally. Of course, we're dealing with tubes of air, and so they're pliable, and the thunderstorm lifts that, bends it up, and you get rotation that now is in the vertical. So you have these energetic air masses that are also favorable for rotation, and those are the types of storms that give rise to the most severe weather. I did put in the lower left, note that the clash of the air masses hypothesis is a myth. It's true that these outbreaks often occur in the vicinity of strong horizontal changes in temperature, but in fact, it's really the vertical superposition of these air masses that gives rise to the most favorable conditions. Now, with that in mind, one thing that we can look for in terms of precursors for active seasons, we can just simply take a look at the conditions that typically occur just prior to the tornado season. Now, before we get into that, one thing I wanted to point out is what do the upper level pattern of high and low pressure systems look like during the active tornado seasons? Many people might wonder that. Meteorologists are very familiar with this, of course, but I've shown this up here in the upper left, and not surprisingly, you have a deep area of low pressure centered over the northwestern United States and a high-pressure system near the east or southeast coast. And it's the wind flow between these two systems from the southwest that often brings together all of these different air masses. Low pressure near the jet stream over the western United States and high pressure over the southeast is usually associated with a jet stream blowing across the Rockies. That actually lowers pressures near the ground, and the contrast between higher pressures to the east and lower pressures in the lee of the Rockies is associated with a strong southerly wind flow near the ground, which transports the moisture and so on and so forth. This pattern tends to bring together, if you will, all of these ingredients in that favorable superposition we just discussed. And this seasonal composite featuring an anomalous vortex over the western U.S. is often the result of a lot of these events occurring over multi-day periods. So, you get enough of these to leave their imprint on the seasonal average. Now, going back to some of the individual ingredients, if you look at the top center, that is what the sea surface temperature distribution tends to look like preceding the most active seasons. And not at all surprisingly, the waters adjacent to the continental U.S., particularly over the Gulf, the lower Gulf Stream and the northwestern Caribbean, tend to be anomalously warm. If you look down below, this is basically February and March to date averaged together. And we have actually quite an anomalous amount of warmth over that same region. Now, the near waters in the Gulf Shelf, they're quite cold because we've had a lot of cold frontal passages this winter. But you don't have to go very far to the south to find anomalous warmth. And, of course, those waters being warmer support higher levels of humidity, which means that the moist air that comes inland has gotten that much more moisture in it, and it's, you get more energy for the storms to grow. So that would appear to be a favorable factor going into the season. If you look over to the right, what I've done top right is I have done the same thing. I've just simply taken the most active tornado seasons, and I've composited February through March jet stream level winds for those seasons. And what you see in the composite, a couple of features stand out. You have a subtropical jet stream that is present in the composite blowing across the southwestern United States through the plains. There's a hint of a flat or a low amplitude high pressure system over the southeastern U.S. and a low pressure system over the northwest, which is not surprising in light of the composite that I showed to the upper left. Again, this is February, March, prior to the heart of the tornado seasons. How about the pattern so far this year? Well, the overriding feature that's worth noting is that we've had a repeated series of high pressure systems in the eastern Pacific, and those have tended also to overlap the western part of the United States. And that's more or less been the opposite of the pattern that we've had during the winter to date. So something would have to change pretty dramatically if going to see an active season. Many active seasons seem to start showing their hand pretty early on, and so far this one hasn't. In fact, most of the eastern United States is obviously still being blanketed with snow and very cold, and that's because we've had low pressure systems not in the west but developing over the central and east. So we need that pattern to change. There is a subtropical jet stream developing, but again, unless it gets involved with some of these low pressure systems that repeatedly form over the west, it won't do much good in terms of developing severe weather patterns. Moving on, I've mentioned El Nino before. That's a basically, we believe that most of our predictability for long-range forecasts comes from different attributes of El Nino. ENSO there, by the way, stands for El Nino Southern Oscillation. Southern Oscillation is basically a seesaw in mean sea level pressures between Tahiti and Darwin, and it's highly correlated with El Nino, meaning that when you have an El Nino, that index tends to be negative because pressures tend to be higher back to the west and lower farther east in the Central Pacific and vice versa. So I looked at the effect of what happens when a tornado season, when that year ends with El Nino. Those are the red pluses. Ignore the colored text at the bottom of the diagram on the left. It's the opposite. The blue circles basically represent the tornado totals for all years that ended in La Nina. The red pluses indicate those tornado season numbers, adjusted numbers, for years that ended in El Nino. And what you see is a subtle decrease in the mean number of tornado occurrences in the El Nino years. And when you do some fancy statistics on that, that of course cannot bring out relationships that simply don't exist in the underlying data, but it can accentuate those that do. What you find is there is a small but significant change in the mean number of tornadoes that occur during El Nino tornado seasons, which unfortunately are drawn here in blue, and the distribution of mean tornado occurrences for La Nina here in red. You see that La Nina years that are trending towards a La Nina, have a slight tendency to be more active. So that's something that's interesting, but that's about the only relationship that I can find. Many other authors have studied this in detail and don't find much of a relationship at all in general. And that's all well and good, but really an individual season comes down to individual patterns that develop. And here's an example of one. I mentioned earlier that last year, by the numbers, was the least active tornado season on record, at least going back to the beginning of the modern record, which we consider to be about 1953-54, for which we have pretty good data once you properly adjust it, as we've done. And what you see here is a few days prior to the most violent tornado period of 2013. In fact, what I've drawn on the left is I've composited the jet stream level winds a few days prior to the Moore tornado, which occurred on May 20th of last year. And I show it because it's very typical of the evolution leading up to major tornado events and severe weather outbreaks in the United States. You have a strong jet stream extended across much of the Pacific from east of the coast of Japan all the way to the northwestern coast of the United States. A few days later, during the period that ended with the Moore tornado day, that jet stream breaks down and the pattern amplifies, depositing a deep vortex, which you can see sort of at the end of that wavy arrow. It sort of makes that bend southward toward Mexico and then back up. That's what the winds do in the base of a strong low pressure system. And that's the kind of evolution that tornadoes occur with. I think many would recognize that as looking similar to what I showed on the composite back on slide, I think it was slide 3. So the jet breaks down, a strong mobile upper level of pressure system develops over the plains, and it facilitates the emergence of this explosive severe weather conditions. These pattern evolutions are not generally predictable more than 10 to 14 days in advance, but a couple of them occurring in a season can strongly dictate the total outcome in terms of impact and numbers for severe weather events, and including tornadoes for a seasonal mean. So to recap, we're likely trending towards an El Nino. The data suggests that might be slightly unfavorable for a very active season. However, the Gulf and Caribbean, aside from the immediate Gulf coastal waters, are rather warm. And so that means if we can get a durable low pressure system or a series of them to develop in the west, we can tap into some of that. And that leads to, I think, an overall slightly favorable skew to the prediction. We do have a developing subtropical jet stream. I would consider that to be conditionally favorable factor for the season, but it has to persist, and more importantly, it has to get involved with troughs that develop. That trough is a term for an open low pressure system. Those have to develop more in the west rather than in the east. Another emerging factor that we're monitoring for is the possibility of blocking. In fact, we've had blocking in some forms most of the winter, mainly over the North Pacific. There's some evidence that this might begin to occur over the Atlantic basin as well. And this in general shifts the storm track southward into the plains and deep south. So that would result in more days on which you had high vertical wind shear values occurring. But it can also result in frequent frontal passages into the Gulf, and therefore not allow for enough time for moisture to come back inland between storm systems. So you can see all these conflicting factors, and that gives rise to the conclusion, which is, I'm sad to say, that making a seasonal tornado prediction is about as hopeless as making an overall hurricane season prediction. In fact, I would say it's about as hopeless as making a prediction of how many landfalls are going to be, in the Gulf Coast or something like that. Now, on statistical grounds alone, overall numbers and activity are not likely to be as low as 2013's record. I mean, it doesn't take a meteorologist or a statistician even to see that. But the present pattern evolution that we see in our subseasonal forecast is not particularly favorable for early season high-end severe weather episodes. Certainly can't rule out individual events, but we don't see anything coming along that would be like a 2011 outbreak or something like that. However, as we get deeper into the season, things can change, and we'll just have to monitor these intra-seasonal weather patterns to catch big severe weather events if and when they are to occur. And that's all I have.
Great, thank you. I will pass it over to Claudia Dent.
Well, thank you. That was really great. I'm just going to spend a few minutes and talk about severe weather and how we partner with WDT to really help you bridge the gap between all these various severe weather events and communication within your organizations, whether it's corporation, state and local government, et cetera. I have to, thank WDT. We have a great partnership. They really enable us to leverage, all of their detailed information to deliver very, smart, targeted, map-driven weather events and alerts, so that we can help our customers, respond and alert all their constituents as quickly and accurately as possible. And I'm just going to talk a little bit about what we've learned over the years to be able to do that. So we know that during a hurricane or a tornado or any kind of major weather event, communication is really critical. And communication during these kinds of events can get, really kind of hairy, right? Because, you look at something like Hurricane Sandy, and, there were about 8 million people without power. Well, how do you communicate with, with people without power? How do you best manage a situation like that? Also, the aftermath of all the property damage, over $25 billion, et cetera, making sure that, everyone is safe, et cetera. So, Everbridge customers leverage the Everbridge communication platform to protect their clients and contacts as much as possible. So during that time period, we did about 25,000 different broadcasts with over 8 million messages. 6 million people were contacted, and we were able to do that with our elastic infrastructure that enables us to manage really large events like Hurricane Sandy. From a Everbridge user perspective, you're able to get a really clear understanding of impending weather events with our integration with WDT. So you see on the screenshot here, there happens to be a blizzard warning. We've seen too many of those this year. I live in Massachusetts. We saw another one today. And when you see these kinds of warnings, you're able to automatically send messages for different audiences based on their role and location, et cetera. So you can pre-establish what messages you want to send out for different audiences, and once a weather alert happens, that communication will be automatic. So you might have one message that you want to go to operations to get them all geared up for cleanup or whatever. Another message that goes to your citizens, your community, your employees, and yet a third message that may go to people who are in facilities management, et cetera, so they can be extra prepared and understand what's coming. So the ability to have an event and automate these different messages is key. And some of the things that we've learned is how to better execute some of these communications, and I'll talk about that after I just show you one more example of a blizzard warning. And we have the same things for hurricanes, tornadoes. Well over 100 different weather events will surface within the Everbridge platform with very specific polygons on the area of impact. One of the key things that we've learned during these events, hurricanes, et cetera, blizzards, tornadoes, is if you're going to reach people, you don't want to just use one device or method of delivery. You always want to use multiple contact paths. That way you have the highest probability of reaching people as quickly as possible, because some of these paths can be compromised during any severe weather. For example, during Hurricane Sandy, one of the first things that happened was all the landlines went down. But people still had wireless connectivity or even cell connectivity. And then, over the course of the day or so, some areas lost all of those. But at least you're leaving yourself as much, probability of reaching people, the more paths that you include in your emergency notifications. Message construction, just some key common sense things. Messages should be very clear and concise. One thing to always keep in the back of your mind is the 3-3-30 rule. 3 short sentences, 3 key messages, and 30 words. And telling people what they should do, even if it means not doing anything, is very, very important. The other thing we've learned is that two-way mobile communication can really help during situations where people may be compromised, but you've got people that are on the front lines that can report back to you on exactly what's happening and send you things like pictures and give you information about their status, whether they're safe, whether they're in harm's way, what they need, etc. And the final point is, in addition to relying on your own frontline intelligence, your own employees or staff, You can also leverage information regarding social intelligence or what's happening on Twitter and other social media feeds. So for example, from a Twitter perspective, this is, you can see that there's a filtered set of Twitter messages that were all happening out, right after Hurricane Sandy. And one of the challenges that people had after Hurricane Sandy was that they couldn't find gas. So hospitals, and many of our customers are hospitals, were struggling to figure out how to get staff to commute because they were really literally running out of gas. So they could leverage social media to give them a sense of, where there was gas, how long the lines were, et cetera. So they could share that, hey, you might not want to go to this gas station. We know for sure, based on social media right now, it's out of gas. And you could see the location of those, et cetera. Likewise, one of the other advantages of social intelligence is being able to see, what happens after the aftermath. So, as you're trying to get crews out to assess damage, you can also rely on geolocated Twitter messages that, enable you to understand what areas are more dangerous than others. And there's a lot of different examples of how social media can be used to understand the trends and get a sense of what's happening, after a weather event or any other kind of, a tragic event. So that's all I just wanted to cover was a brief overview of some of the things that Everbridge is able to do. We were founded in 2002, so we've been around for over 10 years now. We have a large global presence. We have 2,500 clients across all different verticals, and we'd really invite you to reach out to us, and we'd be happy to get a better understanding of what you're looking for in terms of your own requirements and weather issues and who you need to communicate with and how you need to manage your critical communications and operations, and provide you with insight and help. So once again, on behalf of WDT and Everbridge, I really would like to thank everyone for attending today's webinar.
Great. Thank you so much. So at this point, we're going to open it up to questions from our audience. As a reminder, you may submit your questions by typing the question into the open text field in the questions panel on your screen and submitting it to all panelists. And we will answer as many questions as time allows. So the first question I will field to WDT. Given the unpredictable nature of severe weather events, what's the ideal time frame for warning citizens, and I'll add other communities, of impending events?
Would you like me to answer that?
Absolutely.
Okay. Yeah, I just wanted to make sure it was to address directly to me. That's really, you're limited, your time horizon, if I understand the question, is you're limited by the predictability of the particular event. So with hurricanes, we can see them coming. Often you have several days of advanced warning. In fact, I think the Hurricane Center, I think, is expanding the time horizon with which to give the hurricane warnings now. Because there's so much movement of people and resources that have to occur. With tornadoes, you're really limited. The present state of our technology in terms of our ability to predict these things is limited. And unfortunately, tornado days, when the storms develop, things get going very, very quickly. I mean, you can go from partly cloudy skies to a violent tornado situation in 1 hour. And so when you have a long-track tornado situation, like you often see on the big outbreak days, it's easier to give advance warning. In fact, during the big April outbreak, April 27, 2011, there were communities that had warning that there was a tornado likely impacting their area an hour ahead of time. in general, that is far longer than we're able to give in terms of a warning horizon. So it's just situationally dependent, and it's also depends on the scale, the size of the phenomenon, or and all of those things.
Great, and I'll add there's one more clarifying question that came in. Can someone help our company determine when to shut the business down when there's an extreme tornado threat? I don't know if you want to address that specifically, or.
Well, Mickey talked earlier about some of the incredible technology that WDT has. When I came on board, I mean, I was really impressed with it. But being a storm in existence with a radar signature that is highly correlated with, with the threat that you're warning for, whether it be hail or tornadoes or what have you, once that's in existence, then these algorithms are very capable of giving a certain amount of lead time to businesses downstream in the path of the storm. And I think he gave an example of Walgreens, where they could have up in a major long track tornado situation could have as much as 30 minutes to make critical decisions about getting people to shelter, getting medication into protective areas, and so on and so forth. So again, it really depends on the exact situation.
Great, thank you so much. And you're not off the hook yet. The next question is also for you and Mickey. Can you speak to the relation between the high-level tornado predictions you gave and other events like flooding? And then someone else had asked specifically about the western United States provided general spring and summer rain outcasts because of the drought conditions.
Right. Well, the situations that lead to active tornado seasons in general are associated with higher amounts of precipitation, because a necessary condition to have a tornado is to have a thunderstorm. And so if you have a lot of tornadoes, you typically have a lot of storms moving over a region, and sometimes over the same region. We find that these tornado seasons, they tend to concentrate their activity in the same general area many times, although that the activity does gradually shift northwestward per the seasonal cycle. But I haven't actually looked at the direct relationship, but in general, when you have an active severe weather season, you typically have more heavy rainfall. As far as the West, I mean, we seem to be going into a pattern transition right now that might actually provide some drought relief for parts of the West Coast. I mean, we've already seen some events there. And, we've by and large, most of the winter had a really wretched situation consisting of a persistent high-pressure system parked along or near the West Coast. And there's indications now, the pattern appears to be making a move toward a state where they might pick up some beneficial rains. And so that's sort of how it looks right now. I don't know if it can really undo the damage of the winter, but it at least looks like they'll have some opportunities to get a little bit of short-term relief.
Great, thank you. So this next question is for Claudia. Claudia, you mentioned filtered social media. One of the challenges we have with social media is that there's so much content and it's sometimes unreliable. How is social media filtered?
That's a great question. You're absolutely right. There's something like, I don't know, 40, 50 million tweets a day, or something that's inconceivable for anyone to ever, filter manually or gain any interesting information from. So what we provide in Everbridge is a way for you to set thresholds that specify what information you're most interested in, whether it's through hashtags, a particular user, or by geography, or any combination of those things. And those alerts, based on your threshold settings, will surface within the universe, the visualization of where they're occurring, et cetera. And they will also, if you want, will enable to send automated alerts about those as well. So, for example, if you are concerned about bomb threats in the Boston area, you could do a threshold that said, if I hear more than 2 items in a certain period of time that have the word bomb in them in the Boston area within a 25-mile radius, send me an alert. And then I would get an automatic alert, on my mobile phone. Again, multiple modes of communication, email, SMS, phone, etc.
Great. Great. So this next question is for WDT. Other than the typical weather models that pretty much anyone can consult, what types of forecast methods does WDT employ to assess severe weather risk on a weekly basis? Anything better than the National Weather Service?
That's an excellent question. Now, in my department, we often are at the kind of the top of the forecast funnel, if you will. We're here for example, in the Houston branch, we're concerned more with sort of looking at the long range. That's sort of the nature of the forecast problem. But some of these severe weather events, as I said earlier, that the patterns that lead to them generally only begin to show their hand, 10 to 14 days in advance, and sometimes there are certain pattern transitions where they pop up within a week. Inside of that time frame, typically the numerical weather models have a fairly good handle on the overall evolution, and inside of about 5 days, they tend to start to get the details right. But severe weather is very sensitive to the details, and so some of the things that that forecasters here are encouraged to do is to basically, consult multiple models. There's I know here in this office when we're tasked with looking at sort of the longer end of that time scale, because again we're looking at the longer time range. We'll look at probabilities derived from the ensemble. Sometimes the people that just go onto the internet and find these models don't realize that there's a lot of uncertainty information. How confident are we in the model forecast, or how confident are the model forecast in a particular outcome? And there's actually a lot of sites that the general public may not be aware of that meteorologists find and develop all the time that will give you some extra information derived from the ensemble forecasts, which basically are, we run a lot of these models multiple times with slightly perturbed initial inputs, and that we hope, kind of represents, most of the range of the uncertainty in the forecast. So by looking at the distribution of different model forecasts in an intelligent way, meteorologists, I think, are better trained than the general public, and even than some public sector meteorologists at interrogating these types of things, the different, the ensemble of model solutions and deriving probability statements from them. So those are the kind of things we do, give a better estimate of how confident are we in the solution, the uncertainty, if you will.
And Dave, I would add that one of the things that you really want to focus on the time periods where you can really add a lot of value. And for severe weather, that's going to be in the day before or early in the day of the event.
Great, wonderful. And that's a great segue into our next question, which is for Claudia. Can you walk us through the process about warning employees in the potential threat path prior to the event, and then gaining post-event updates on the safe and wellness status of their both personal employees and their families that were in the path of the event?
Yeah, sure. I think that's an excellent question. A few points. I do think it is important to realize that communication, during an event like Hurricane Sandy or anything like that, or if that there's there might be some impending tornadoes, it's really important to communicate in advance as much as possible with what you want people to do. So a plan, so make sure that everyone has a plan and they understand what they're supposed to do during the event of the emergency, and then communicating with them during the emergency as much as possible to see if they're safe, et cetera, and to see if there's any actions, proactive actions that you can take. And then finally, communicating after the event as well. All of those, communications, it's, best to use the best practices we talked about earlier. multimodal communication. But it's also important, particularly in these kinds of severe situations, to also track and understand who has received your message and confirmed it, which the Everbridge system does. It will tell you who received it, what mode of communication they received it on, so you can start to see patterns around which modes of communication are working more effectively than others. And also, you can do things like send follow-up to people who did not respond, or you can leverage polling messages to say, yes, I'm safe, I'm fine. To, I'm not, we're okay, but our house was severely damaged. So you can reach out to just those people who have maybe shelter issues and make sure that they can find shelter, et cetera. So the system is really flexible in letting you, build out these kinds of communication and response patterns.
Great, thank you so much. So unfortunately, I think we are out of time. If you asked a question that wasn't answered, we'll do our best to follow up with you after the webinar. But I'd like to thank Mickey, David, and Claudia for a great session. And I'd also like to thank all of our attendees who were able to join us today. So if you missed any part of the webinar, be sure to look for the slides on everbridge.com/blog. And you'll also receive an email with a link to the recording in the coming days. So if you haven't already, please take a moment to follow us on Twitter at Everbridge and join our group on LinkedIn, Everbridge Incident Management and Emergency Notification Professionals. And for those of you interested in requesting a demo of the Everbridge system, including the WDT integration, please visit everbridge.com/request-demo. So thank you all again for your participation in today's Expert Insights webinar, Severe Weather 2014, Predictions and Best Practices with WDT, and we hope to see you online again soon. Have a great day. Thank you, everyone.